Welcome to the Responsive UI in Flutter course, where you will learn how to create stunning user interfaces that adapt seamlessly to every device and screen size. But first, what exactly is Responsive UI? Well, Responsive UI is the art of designing and developing user interfaces that allows your app to adapt to different screen sizes and resolutions. This means that if your app have a responsive UI, it will look great on phones, tablets, and even on desktop computers. Now the next question pops up, which is why responsive UI is so important. Imagine an app that looks pixel perfect on a phone, but if we run it on a tablet device, it turns into a mess, which is not a good experience. Well, responsive UI prevents this by ensuring that your app is accessible to everyone. Nowadays, people are using variety of devices. If your app is not responsive, it will be only accessible to small subset of users. In this course, we will cover everything you need to know, from the fundamentals of the responsive design to advanced techniques of handling different screen orientations and device types. With hands-on example and step-by-step guidance, you will learn how to get screen size of any device, how to create adaptive layouts, how to use Layout Builder, and many more. Throughout the course, we will apply our learning by developing a tour app that showcases stunning destinations. You will also witness the transformation of static designs into dynamic responsive layout that attracts users. Whether you are a seasoned developer or just starting out, this course is tailored to accommodate all skill levels. We will guide you through step by step, ensuring that you are equipped with the skills needed to get into the world of responsive UI design. So get ready to take this course and unlock the secret of creating beautiful and user-friendly interfaces in Flutter. In this video, we will talk about the responsive design theory, following the principle of material design created by Google to help you build visually appealing and responsive Flutter apps across various devices. Let's start by addressing the problems we encounter with the non-responsive designs. First, they can be difficult to use on a smaller screens. If you are trying to view a website on your phone and the text is too small to read or the images are too big to see, it's not going to be a very good experience. For example, let's say you're trying to read an article on a website that's not responsive. The text might be too small to read on your phone and the images might be too big to see. This can make it difficult to follow the article and get the information you need. Secondly, non-responsive design can look unprofessional. If your app looks not good depending on the screen size it's being viewed on, it can make your business looks like it doesn't care about its users. There are few things that we need to consider when designing a responsive app. First, we need to think about the different screen sizes that our app will be viewed on. This includes desktop, computers, laptops, tablets, and smartphones. Then we need to decide how our app will behave on different screen sizes. Do we want the content to stay the same size and just get resized, or do we want the content to rearrange itself so that it's still easy to read and use? So the Google Material Design has provided us some very good guidelines on how to implement a responsive layout. So here we have one fundamental concept called responsive layout grid. A responsive layout grid is a way of organizing the content on your app so that it looks good on different screen sizes. Responsive layout grid has some important concepts that drive their effectiveness in responsive design. Let's start with the columns. Column defines the horizontal divisions within a screen or container. They provide structure and help organize the placement of the UI elements. Gutters are the spaces between columns and serve as a visual separation, preventing the UI elements from appearing too crowded. They contribute to the overall readability and aesthetic of the layout. Margin also play a crucial role in responsive layout grids. They define the space between the outer edges of the screen or the container and the columns. The margins create a visual breathing room and help establish a sense of hierarchy within the layout. Now let's talk about the breakpoints. Breakpoints are specific screen widths where the layout grid adapts to the different devices. They define points at which the number of columns, gutter sizes, and even margins may change to accommodate varying screen sizes. By defining breakpoints in our code, we can create layouts that respond fluidly as screen size changes, providing optimal user experience on various devices. So the material design recommends 600 dp as the first breakpoint, so the screen size below 600 dp will result in mobile layout. And for any screen size more than 600 dp and below 840 dp, it will result in a tablet layout. And any screen size more than 840 dp, it will be considered as a desktop layout. So these are the breakpoints where our app will change its layout. We also want the content of the app to rearrange itself when the layout changes, so it's still easy to read and use. For that, we will make use of the material design patterns. Here are some common patterns that we can use. So the first one is reveal. This pattern hides the content on a smaller screens and reveals it on the larger screen. For example, you might have a sidebar that's hidden on smartphones and tablets, but it is revealed on the desktop computers because there is enough space available. Now let's talk about the transform. This pattern changes the way content is displayed on smaller screens. For example, you might have a text column that turns into a button on a desktop. We can also use divide. This pattern divides content into smaller columns on smaller screens. For example, you might have a single column that divides into 2 columns on smaller screens. So by all means, responsive design is very important because it ensures that your app is accessible to everyone regardless of the device they are using. From the last video, we have a good understanding of the responsive design. Now we can start thinking about how we can build our app that adapts and adjusts seamlessly to different screen sizes and orientations. And I think the best way of doing this is to figure out what kind of architecture we need. The first thing in building a responsive app is to think about how many layouts we will have. Basically, for our app, we will have 3 layouts that we need to build in order for our app to be responsive, which is mobile, tablet, and desktop layout. Before starting the development, first we need to establish our strategy. Should we start from a mobile layout and then scale the interface up to the higher resolution? Or maybe we should start from a desktop and scale the interface down to accommodate the mobile device. The approach while scaling up is known as progressive advancement or mobile first design, in which first we design our UI for the mobile devices and then scale it up to the higher resolution like tablet, desktop. In this course, we will follow this approach while building our app. So here is our tour app that we are going to build within this course, and if I changes its window size, its layout changes respectively. On the mobile layout, we have the navigation menu hidden and it can be revealed using the app menu button. The tablet layout, the navigation menu is revealed because we have enough space available on the screen. Same for the desktop layout, the navigation menu is revealed because we have enough space available on the screen. In mobile and tablet layout, we have vertical gallery of different places, but when the size of the screen increases, it is transformed into horizontal gallery. And finally, the place which is selected, the details and the picture will be shown in the detail panel, whereas it will be hidden within the mobile and tablet mode. And when the user click on it, they will navigate to the detail screen where they can see the details of this. Now let's talk about the implementation details. In order to build the responsive UI in Flutter, we need to understand different things like this. How does the app know its window size has crossed a certain breakpoint range so that we can switch our layout? How does our app know when its device orientation changes from portrait to the landscape, or landscape to portrait, so that our layout should be adjusted accordingly? How does an individual widget know its new size and fill the available space available on the screen? So to solve these problems, Flutter has provided us with the 3 main widgets: Media Query, Layout Builder, and Orientation Builder. Using these 3 widgets, we can build responsive UIs in Flutter. Of course, Flutter has provided more useful widgets and packages which we can use to manipulate or rearrange layout structure or UI components. So hopefully this video has given you some insight about how we will build our app. In this section, we will be talking about the media query and how we can use it to access the device screen size, and based on the device screen size, then decide to display different layout. MediaQuery.op is a method in a Flutter framework that allows us to access information about the dimensions and layout of the device screen. We can use it to access vital information about the device, such as screen width, height, device orientation, and more. To use MediaQuery.op, we need to pass it a build context object, which we can get from a context argument in the build method of a stateful or a stateless widget. Now let's get into implementation. In my main method, I'm running my app, which returns a material app, and inside we are passing our home page, which we will create inside the pages folder, and it is a stateless widget which returns a scaffold. First of all, we will create a widgets folder within the lib directory, and inside we will create responsive widget.dart file. Here we will create a class responsive widget, which is a stateless widget, and this widget will encapsulate all the logic around creating a responsive design. In the responsive widget, first of all, we will define 3 variables of type widget and mark it required within the constructor except the tablet variable. Now we will create a method isMobile of type boolean, and inside we will call MediaQuery.op context.size.width, which provide us the size information of the device, and we will compare it with our first breakpoint. If the screen width is less than 600 600 dp, then this method will return true. Same for the tablet layout, we will create isTablet method of type boolean, and inside we will call mediaQuery.offContext.size.width, which provide us the size information of the device, and we will compare it with the breakpoints. It will return true if the screen width is less than 840 dp. Now for the desktop layout, we will create isDesktop method of type boolean, and inside we will call mediaQuery.offContext.size.width, which provide us the size information of the device, and we will compare it with the breakpoints. It will return true if the screen width is greater than or equal to 840 dp. Now within the build method of responsive widget, we will check if isMobile returns true, means that the screen width is less than 600 dp, then we will return mobile widget that we get from the home page. Else if we will check if isTablet returns true, then we will return tablet widget, otherwise we will return the desktop widget. Now coming to the home page, here we will pass responsive widget to the body of the scaffold. For mobile, tablet and desktop arguments, we will create 3 different methods: build mobile, build tablet, and build desktop. Each of them will return a container widget with a different color and a center text widget indicating each layout. After hard loading, here you can see that when I change the screen size, the media query method is invoked, and based on the device screen width, it will return different layouts. In this section of the course, I'll be creating a model class for our app, as we will be creating a tour app in this course in which the user can see details about different places. Therefore, every place will have its own picture, title, subtitle, and description. So for this, first of all, we will create a model folder within the lib directory, and inside we will create a place.dart file. Here we will create a class place, and inside we will define all the attributes and mark it required within the constructor. For the images of the places, we will create images folder, and inside we will add all the images that we want to use later. After that, we will go to the pubs.yaml file and define our images folder inside the assets. After that, we will create another folder data within the lib directory, and inside we will create places.dart file. Here we will create a list of all places which will hold the data of the places. Within the all places list, we will call place and pass the relative data of each place to its attributes, which we will access later within the app UI. We will also create stats.dart file inside the data folder. Here we will create a list of all stats which will hold the names of the different stats that we will display later within the app UI. With this, our model class and data is ready to be used. In this section, I'll be talking about how we can create our tour app UI using different adaptive layout. First of all, in the home page, within the scaffold, we will define an app bar for our app which will stay consistent throughout the app. We also want to add the drawer to our tour app where the user can see the stats of the country. Therefore, within the build method, we will create a variable isMobile and assign it to the responsive widget.isMobile context to check if the current device is mobile. After that, for the drawer, we will check if isMobile is true. Then we will access the drawer widget, and inside we will pass drawer widget, which we will create separately. Therefore, we will create drawer widget.dart file within the widgets folder. Here we will create a class drawer widget, which is a stateless widget, and it returns a list view builder. For the item count, we will access the length of all stats list and add one with it because we want to build the drawer header also. For the item builder, first we will check if the index is equal to 0. Then we will return a build header method. Otherwise, we will return build a menu item method to build the naming list of the stats. Now we will create these methods. First of all, we will create build header method of type widget, and it will return a drawer header widget. For the decoration, we will use box decoration, and inside we will pass image to give the drawer header a nice background image. For the child, it will return a container widget, and inside we will use a text widget with some custom text style to give it a nice look. With this, our drawer header is ready, and now we will create the drawer menu items. For that, we will create build menu item method of type widget, which will take index as a parameter, and it will return a list style widget. For the leading, we will pass an icon widget to give it the location city icon. For the title, we will pass a text widget, and inside we will access the name of the stat from the all stats list using index, but we will subtract one from the index because the extra one position was for the drawer header only. With this, here you can see that when we click on this icon, we have the drawer ready. Now we also want to build the gallery of the places so that we can see the images of different places and also can click on it. Therefore, we will create place gallery widget.dart file within the widgets folder. Here we will create a class place gallery widget which returns a container widget with a gray color. Here we want to show the places image within the grids. Therefore, we will use gridview.count. Later, the cross-axis count will rely on the screen size when we are working with a tablet or desktop layout, but for now we will set it 2 items per row. For the mobile layout, we also want to make it vertically scrollable. Therefore, we will set the scroll direction to x start vertical. For the children, we will map the list of all places using .map method, and every time we get the place, we will call the grid item widget, which we will create separately. Therefore, we will create grid item widget.dart file within the widgets folder, and here we will create a class grid item widget, which is a stateless widget, and it returns a card widget. First of all, we will create an instance of the class place and mark it required within the constructor. Now coming to the place gallery widget, here inside the map method, every time we get the place, we will pass it to the required parameter of the grid item widget. Now coming back to the grid item widget, here within the card widget, for the clip behavior, we will use clip.anti-alias, which clips the edge of the card to achieve a smoother look. We will also give it elevation to make it looks good. For the shape of the card, we will use rounded rectangle border, and inside we will give it a circular border radius. For the child of the grid tile, we will use ink.image because it creates a widget that shows an image. Therefore, inside we will use the image property to access the images of the places. For the fit, we will use boxFit.cover, which will make the images cover the whole available space. After hard reloading, here you can see that we have our places gallery ready. Now we also want every image to have a title. Therefore, we will use the footer property of the grid tile, and here we will pass the grid tile bar. We will give it a background color, and for the title we will use a text widget to access the title of the place. Same goes for the subtitle. We will use a text widget to access the subtitle of the place. After hard reloading, here you can see that every place have its own title and subtitle. We also want the grid tile to be clickable so that we can see more details about the place. Therefore, we will wrap the grid tile with the inkwell, and for the ontap function, we will use navigator.offcontext.push method to navigate to the details page, which we will create within the pages folder. Here we will create a class details page, which is a stateless widget, and it returns a scaffold with the app bar, as we want to display the details of the specific place that is clicked by the user. Therefore, we will create an instance of the class place and mark it required within the constructor. Within the app bar, we will pass a text widget to the title, and inside we will access the subtitle of the place. For the body of the scaffold, we will pass the place details widget, which requires the place as a parameter, and we will create it within the widgets folder. Here we will create a place details widget, which is a stateless widget, and it returns a list view widget, as we want to display the details of the specific place that is clicked by the user. Therefore, we will create an instance of the class place and mark it required within the constructor. After that, inside the list view, we will add the image.asset, and inside we will access the image of the clicked place using the place.image. We will also set a custom height and width of the image to fill all the available space. We also want to access the title and subtitle of the place below the image. Therefore, we will call build title method, which we will create separately, and it will return a container widget. Here we will pass a row widget as a child of the container widget. For the children of the row widget, we will pass a column widget, and inside we will access the title and subtitle of using the text widget with some custom text styling. We will also add a star icon with some text within the children of a row widget. We also need to create a buttons within the list view. Therefore, we will create build button methods, which will take color as a parameter, and it will return a row widget. Here within the children of the row widget, we will call build button methods, which is a separate widget, and it takes color, icon, and label as a parameter. We will call build button methods 3 times, and each time we will pass different icon, label, but the color of the icons will remain the same. Same for the description. We also want to access the description of the place. Therefore, within the list view, after calling the build buttons method, we will call build description method, which returns a text widget with some padding, and inside we will access the description through place.description. With this, our app UI is almost completed. We have the places gallery where we can see different places, and when we click on any place, we will be navigated to the details page of the place. Well, that's all for this section. Next, we will adjust our UI to the tablet screen. In this section, I'll be adjusting the UI of our app that we built within the last video to the tablet screen. Till now everything is good, but when we increase the size of the window or we run our app on a tablet device, our UI is not responsive. Therefore, we will adjust our app UI to the tablet screen as well to make our app responsive. For that, within the home page, we will go to the build tablet method. Here it will return a row widget. The idea is that we will divide our tablet screen into 2 parts. In the first part, we will display the drawer on the screen when our app is running on a tablet, and in the second part, we will have a vertical gallery of different places. For this, we will be using the expanded widgets with a flex property to split the screen within 2 parts. Using an expanded widget makes a child of a row, column, or flex expand to fill the available space. Basically, using the flex property, we can decide to distribute the available space on the screen unevenly among the children widgets. For example, here we want to distribute the available space within the 7 portions. Flex 2 for the drawer represents 2 portions will be occupied by the drawer, while the flex 5 represents that the remaining 5 portions will be occupied by the places gallery widget. Now coming back to the implementation, inside the row widget we will create an expanded widget with a flex 2, and inside we will pass our drawer widget method because we want to show our drawer when our app is running on a tablet device. With this, when the window size crosses the breakpoint, the drawer will be displayed automatically on the screen. We also want to show the places next to the drawer within the tablet mode. Therefore, we will create another expanded widget with a flex of 5 and pass out the place gallery as a child of the expanded widget. After hard reloading, here you can see that when the window size increases, the layout is changed from a mobile to the tablet and the UI is adjusted accordingly. But still, if you notice, the text is still not responsive. Means that on the tablet layout, the text is too small to read. Therefore, we need to make our text responsive as well. To make our text responsive, we will make use of the auto size text package. Therefore, we will go to our puffs.yml file, and here under the dependencies, we will define our package. Now let's see which text needs to be responsive when the layout changes from a mobile to a tablet. So first of all, we want to resize the text of a drawer when the layout changes. Therefore, going to the drawer widget, within the build method, first of all, we will access the width of a screen using the mediaquery.offContext.size.width and multiply it with a 0.025 to get some number, and then save it within the font size variable. Now coming to the build header method, first of all, we will add a parameter font size of type double, and after that we will replace the text widget with the auto size text widget to make our text responsive. Inside we will specify the min font size and max font size for our text, and also give it the font size within the text style which we get from the screen width. Same applies for the build menu item method. First of all, we will add a parameter font size of type double, and after that we will replace the text widget with the auto size text widget to make our text responsive. Inside we will also specify the min font size and max font size for our text, and also give it the font size within the text style which we will get from the screen width. After hard loading, here you can see that if we change the window size, the drawer text is also resizing, and now it is readable. Now we also want to make the title and subtitle of the places responsive. Therefore, we will go to the grid item widget. Here within the build method, first of all, we will access the width of the screen using the mediaquery.offContext.size.width and multiply it with the 0.025 to get some number, and then save it within the font size variable. After that, within the grid tile bar, for the title, we will replace the text widget with the auto size text widget to make our title responsive. Inside, we will also specify the min font size and max font size for our title to make it responsive, and also give it the font size within the text style which we get from the screen width. Same applies for the subtitle, and we will replace the text widget with the auto size text widget to make our subtitle responsive. After hard reloading, here you can see that when the window size increases, the text also resizes itself accordingly. Now if we click on a place in a tablet layout, here you can see that the title, subtitle and description text is very small and is unable to read clearly. Therefore, we also need to make it responsive. For that, we will go to the place details widget, and within the build method, first we will access the width of a screen using the mediaquery.offContext.size.width and multiply it with a 0.025 to get some number, and then save it within the font size variable. After that, we will pass it to the build title and build description methods. Now coming to the build title method, first of all, we will add a parameter font size of type double, and after that within the column widget, we will replace the text widget with the auto size text widget to make our text responsive. Inside for this, we will also specify the min font size and max font size for our text, and also give it the font size within the text style which we get from the screen width. Same goes for the subtitle. We will replace the text widget with the auto size text and give it some properties. Now coming to the build description method, first of all, we will add the parameter font size of type double, and after that we will replace the text widget with auto size text widget to make our description responsive. Inside we will specify the min font size and max font size for our text, and also give it the font size within the text style which we get from the screen width. After hard reloading, here you can see that our text is now fully responsive when the layout changes. With this, our tablet mode is ready, and in the next part we will talk about the layout builder. In this section, I'll be talking about the layout builder and how we can change the size and position of any widget using the layout builder. Now we have a mobile and tablet layout ready, but in the tablet layout, if we click on any place, the details are not shown in a great way. The image is stretched out and the title is also in the bottom, and same for the description. To fix this, we will use the layout builder, which allows us to know the screen size using constraints and help us out in building widgets. Now let's talk about the layout builder. Using the layout builder, we can build a layout or widget in different sizes. One of the main benefits of the layout builder is that it provides us with the local size constraints from which we can extract max width, max height, and min height. To use the layout builder, we will go to the place details widget, and within the build method, we will return a layout builder. For the builder, whenever there is any change within the window size, there is tablet layout or desktop layout, the builder method will be invoked and it will give us the constraints of the current window size, which includes the max width, max height, and min height. Therefore, using the max width, we will check if it is greater than the breakpoint, which is 600. Then we will call the build large widget, otherwise we will call the build small widget. The build small widget will return a list view, and inside we will pass the image of the place, build title, build buttons, and lastly the build description. For the build layer widget, it will return a card widget. To make the card edges smoother, we will use the clip.anti-alias. We will also add elevation and some margins to make it look good. As for the tablet layout, we want it to be more like in the landscape mode, and therefore we will pass a row widget as a child of the card widget. Inside the row widget, we will create two expanded widgets, one for the image and title of the place and another for the buttons and description of the place. Lastly, we will wrap our card with a single child scroll view because we want our card to be scrollable later when we are viewing it within the phone in a landscape mode. With this, when we tap on any place within the tablet layout, the details of the place will be shown in a great way, and if we decrease the size of the window, it will change its layout to the mobile. In this section, I'll be adjusting our tour app UI to the desktop screen and also talks about how the UI will adjust itself when the screen size changes. Till now everything is good, but when we increase the size of the window or we run our app on a web or desktop mode, then it's not responsive. As we already have created our app UI, now we need to make it responsive so that it automatically adjusts and reshape itself to the desktop layout. The idea is that we will split the desktop layout within 3 parts because we have enough space available on the screen. First part will be assigned to the drawer, while in the second part we will have our places gallery. And lastly, when the user select any place, we will also display the details of the place below the places gallery. For that, first of all, within the home page, we will go to the build desktop method, and here it will return a row widget. Inside the row widget, we will create an expanded widget, and inside we will pass our drawer widget method because we want to show our drawer when our app is running on a desktop device. With this, when the window size crosses the breakpoint, the drawer will be displayed automatically within the desktop layout. We also want to show the places next to the drawer within the desktop layout. Therefore, we will create another expanded widget with a flex of 3 and pass the build body widget to it, which we will create separately. The build body method will return a container widget. Inside, we will give it a color and also some parent. For the child, we will pass a column widget. Inside the column widget, first we will create an expanded widget and pass our place gallery widget as a child of the expanded widget. And after that, we will create another expanded widget with a flex of 2 and pass our place details widget as a child of the expanded widget because we want to show it right below the places gallery. We also want to change the style of the places gallery within the desktop layout. Therefore, at the top of the home page, we will create a variable selected place of type place, and initially we will assign it to the places gallery from all places list. After that, we will create a method change place which will take an instance of the class place, and inside we will toggle the value of the place to the selected place. Now within the places gallery widget, we will create a function on place change of type value change, which will be used to select the new place. We will also create another variable is horizontal of type boolean, and initially we will set it to false within the constructor by default. After that, within the grid view.count, we will check if is horizontal is true, which is only for the desktop layout. Then we will set the cross axis count to 1 and axis direction to the axis.horizontal. This is because in the desktop layout, we want our places gallery to be horizontally scrollable. If that is horizontal is false, which is in mobile and tablet layout, then we will set the cross axis count to 2 and axis direction to axis.vertical because we want our places gallery to be vertically scrollable. In grid item widget, we will also create a function on place change of type value change and assign it within the constructor. Whenever we tap on any place, we want to show the details of that place right under the places gallery widget within the desktop mode. Therefore, within the onTap function of inkwell, first we will check if our app is running on a mobile device using the reusable widget responsive widget.isMobile, and then we will save it within the isMobile variable. Same for the tablet, we will check if our app is running on a tablet device using the responsive widget.isTablet, and then we will save it within the isTablet variable. After that, we will see if isMobile or isTablet case is true, then we will navigate to the details page because it will be phone or tablet layout. Otherwise, we will pass the place that we have selected to the function on place chain. After hard loading here, you can see that when we tap on any place, the details of the place is then displayed over here. Now we have one another problem within the desktop layout. We are unable to scroll horizontally. Therefore, to add horizontal scroll in desktop layout, we will define our pointers and assign it to the scroll behavior within the Material app. After hard reloading here, you can see that we are now able to scroll horizontally. With this, our Tour app UI is now completely responsive throughout the different layouts. Here you can see that when we increase the window size, our UI is adjusted to the desktop layout accordingly. Well, that's how we can create responsive UI in Flutter.